Alright, today was estimated values. Now I understand how this works. But we'll do the actual hands-on next week. But as for how to get these numbers, or at least where they go, I understand it now. I got to do all these little extra notes and stuff in order to pull that off. But I get it. But with these two pieces of paper, I can fill this out. With these two pieces of paper, I can fill this all out now. Now we just gotta do it with the hands-on application, and we should be good. All right, so check this out. What we have here, this was estimated values, the lab. We didn't get to the lab portion because I was like, hey, how about maybe we go step by step. Yeah, we spent the whole class just doing this document. So there's 2 pages worth of it. You got this page, and then you have this page. And some of the values were made up just to give you an example. But then they also tell you how to find the values as well. So like, you're starting up here at the top. Let me fold this down. And then, so you find out what the indoor temperature, you can get that old thermostat reading. And then here's the outdoor temperature. You could basically use any weather app or even your smartphone to tell what's the temperature of your current location. The weather app is fine. So you got these 2 right there. You have to find out what metering device is, if it's fixed orifice, which means it doesn't change shape, or a TXV, which is a thermal expansion valve, which means as temperature changes, the size of the valve changes. Then you find out the refrigerant, which a lot of times it'll be on the panel. Then you have the RLA, which also on the panel, and then right here, Subcool, and then you have to find the SEER rating, which most systems will be between this 13 and 15, and then the Subcool will also be on the panel. If not, you're gonna have to check the charging chart or Google the literature. So after you fill in all that in, and then you come down here on this, you already have this because it's right there. It's right there. And then you come up here, you find out what the supply is, and you can get the supply from what temperature is coming out of the vents. And then you're just subtracting this from this to get this. And then, seeing the arrows are kind of nice, so boom, you start here, and then bang, and then bang, then bang here. And we're gonna come over here, and you get 50. 50 is... 50 is 80, the indoor temp minus the 30. Where did 30 come from? 30 came from, I just saw that. Where did 30? $30 degrees to get this. Because sometimes you don't get it in order. You don't get it from this one, then this one, then this one. Sometimes you start here and then get that, blah, blah, or like, depending on how the question is asking. But we got this 50. 80 minus... Where did this 30 come from? It's literally right there. It's right there. 30 below IA, which is indoor air. So you're taking this number, and then you're subtracting it from this number. 30, it's right there, and then you get 50. 50 goes here. And then with the 50, you come to this chart right here. 50, and then you come across, because we already know the refrigerant is the 410A, because it's on the panel. So you got the 410A, you got the temperature, and then you come over here, and I believe these are saturation temperatures. These are sat temps, which means boiling, right? So come over here, and then you get the 142.6, and that's for that one. And then you come down here, you got that, and do the same thing here. Oh, well, we'll just continue on this side, and then you have the 60 degrees sensible temp. How did we get the sensible temp? How did we get the sensible temp? Yeah, so we added this to this to get this. Added this to this to get this. Same thing here with this bad boy. So we had the 105 to 110. And how we got that is 105. There we go. So you got to get this one, you take the outdoor temperature, which is 95 degrees, and then you know what this is, the SEER, which was 13 to 15. That rating, most systems within the last, I think, 20 years are usually in this rating. It may not be on the panel. but you have the outdoor temperature, you have the SEER reading. So then we go to the back, and then we see that 13 to 15 is right there. 13 to 16 is an additional 10 to 15 OA. So then we take this and then we add an extra 10 to 15. So there's for the 10 and there's for the 15. So 105 to 110 degrees, you put that here. And we already know what the refrigerant is. So then we go back to our chart here. And you'll notice two small words. This is dew and this is bubble. So this is going to be our dew. See how it says dew? And then this down here is going to be our bubble. So this was for that first number, and now we're on our second number. So we're going to be down here. And then we're going to go to the 105 to 110. Now there's calculators that can get this more precise, because you see these are all odd. I mean, these are all even numbers, and we have an odd and an even. So there's a calculator by a company called Danfoss, DANFOSS, and they'll give you the exact numbers. But this is still within that range of is that 366, and then somewhere around 346. But the exact numbers can be 342 and 366. That's what we came out with the calculations. And so you have that. So our subcool is going to be 8 because it's up here, because this is on the panel. Subcool is going to be 8. So you're just bringing that down here, and then you're getting that, and you're subtracting from that to get this 97 to 102. So 8 minus these two numbers individually. So 8 minus 105 is going to be 97. 8 minus 110 is going to be 102. So you got that. Boom. So this is all complete. Now for this one, there's a chart right here on the back, these equations. So IA, internal ambient, so internal air temperature, minus OA, outdoor air temperature. See right here, the 80 and the 90, plus equals the degrees. So you add them up and you get these degrees, 175. And then you take that 175. So right here, the 85 and the 90, indoor and outdoor temperature, equals 175. And you come down here to this chart, and you look right here. So 175 is in between 180 and 170. So it would be like right here. So it would be at 85. Because 180 is 90%, 170 is 80%, so 175 is 85%. Then we multiply that 85% times 12.5 RLA. And where we got RLA was up here from the panel. And then we get that 12.5 RLA times the 85%, and it'll equal 10.62 amperage. And that'll be our compressor amps, the 10.62. And now we have all of our numbers complete. And that's the equation right there. IA plus OA equals 175 times 85%. Then the 85% times the RLA, 12.5, equals 10.62 compressor amps. That's what's expected. Then we move on to what's actual. So we come down here, and we started over here. What is our temperature? It was 80. And then we came up here, and what's coming out of the vents? 70. You're just subtracting, and you get the delta T at 10. 80 minus 70 is 10. So then, and remember the 80, this indoor temp can come right off the thermostat. This is coming out, what's directly coming out of the vents, right? And then delta T, then we're gonna come over here, and we're doing the same thing. Low pressure, and we hooked up the gauges. The low pressure gauge is 110. The saturation temp was 36. How did we get that 36? So some of these we might have just been throwing it in, but this is like pretending. This is like pretend actual, right? So if it was 36, right? We hooked up the because he verbally told us. So we got 110, and then the stat temp is 36 over here. We got 56 on the sensible temp. Superheat is 20, and so down here was 20 greater or less than this superheat, and you'll say, well, it's greater than, so it gives an arrow. You put an arrow there. This number is higher than this number. What's expected? So this is what's expected. This is what's actual. The actual is higher. Come down here. You do the same thing. Pressure. This is what you get off the high pressure gauge. These are the stat temperatures. Comes down here. Super cool. This is lower than what we expected, because what we expected was 8. Same thing for the compressor amps. You're doing this off an amp clamp. The multimeter. You got 8 amps. This is actual, so this is lower. And from that original temp, we see that our delta T is 10, even though it's supposed to be 20. It's expected to be 20. So then you take all those, the superheat, the subcool, the low pressure, the high pressure, the amps, the delta T, and you put them up. Is it higher or lower than what it expected? So for the superheat, we see that it's higher. You get a plus arrow up. For subcool, it's lower. Got that? For the low pressure, it's 110. It's supposed to be 146. 142.6, so it's lower. High pressure is 2. I'm saying we were going by temperature. Please remember. So same thing, but it's still the same thing. 36 is what we got, but it's supposed to be 50, so it's lower. High pressure is supposed to be 91. 91. And it's supposed to be up there at 105, 110, so it's lower. Amps, we're supposed to be 10.6, but we got A, so it's lower. So once again, and the last one, delta T, it's 10, but it's supposed to be 20. So once again, it's lower. So you take up, down, 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 and then you go over to this chart right here, and you match it up. What has one up in the front, and the rest are down? You go all the way down, it's undercharged. Because you match up you write it out in the order that the chart has, the SH, SC, LP, HP, A, and delta T. You write it out in the same order, and you'll see that, see this one's down, these two are up as well, but you see the rest of them are kind of up too. So we're looking for the one that matches this scheme. Up, down, 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 down for the rest of them. Up, down, 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 down for the rest of them, and you're matching up, making sure that they're all correct in that same order with the letters. And you'll see that the problem is that this is an undercharged system.